Hi, good afternoon. Thank you everyone for being here, and thank you for the judges to allow us to present. My name is Bruno Nojosa, and I'm the team lead of the Michigan State's Solar Engineers. And our team has been tasked with the challenge. Sorry, Ben, I'm still
too quick. Sorry.
Yeah, our team has been challenged with the task of developing the PV system and battery storage system for the Cheyney University of Pennsylvania. Next slide. This is our team, and it is composed of one PhD student, two master's students, and three undergraduate students, and all of us are either electrical engineers or electrical and computer engineers. We also counted with the help and mentorship of Dr. Lee Wongul, who is a PhD, who has a PhD in electrical and computer engineering. Next slide. So Cheyney University is a relatively small university that has around 600 students a year. So for that reason, we opted for a more simple design and smaller scale. Cheyney University District use case had two challenge areas, which was challenge area 1 was the north side of the campus, and challenge area 2 was the south side of the campus. So to have all of our systems more closely together and to simplify wiring and routing, we opted to build all of our proposed designs on challenge area number 1, which is the north side of the campus. The developed buildings that we proposed were the 2 parking lot areas, as you can see on the screen, and the Hill Library and the Duckery Science Building. The reason why we chose the challenge area 1 over challenge area 2 was that the power substation at Cheyney University and the switch gears of the university is located in the north side of the campus. And this will lower any sort of power losses during the wiring.
As for the development plan, for the planning part of it, this project will be compliant with relevant local ordinances of Thornsbury Township of, I believe it is Chester County. So solar and renewable energy systems, for that matter, are an acceptable accessory use for the Thornsbury Township R1 zoning code, which Cheyney University, at least the north end, is classified under. This project will also be fire code compliant. There is no development planned for this project in the south part of campus for a couple different reasons, but one of those main reasons is that it is under a different township with different ordinances and different zoning codes. So to simplify it, we're just keeping it all in one area. As this proposal is entirely in challenge area 1, we are making the assumption that it does not conflict with Cheyney's master plan. We were unable to find specific buildings that Cheyney is targeting for its master plan. And none of the sites that we selected seem to conflict with anything we could find for that. As for the permitting part of this, for all the parts of it, we're going to need zoning and building permits. We're going to need fire code approval. And then for any lines that we lay in the ground, we're going to need electrical permits as well. This development is not planned on any historical buildings. Fortunately, there are no historical districts, to my understanding, on Cheyney University, but there are historical buildings, which we are not planning to touch. And then as far as construction, the current plan will take somewhere in the range of 1 year to complete, but this is kind of up in the air depending on how the permitting process goes.
And to get to the next slide, sorry, you'll have to re-click because I unfortunately moved my mouse. There you go.
Okay, perfect. So for our tentative construction schedule, we have about roughly 6 phases for it. That will take roughly 11 months. So for the first phase, our site overview, selecting the administrators should not take very long. Hiring the consultants to administer the process along with the administrators, we planned for about 2 months. And then scouting the site to check out everything and make sure that any potential problem areas are documented should also take probably 1 to 2 months. Permitting is a really rough approximation. We gave it roughly 4 months to apply and secure permits, but if the township or anybody involved with the township demands changes or doesn't like a project, this could run longer. Financing, we gave it about 2 months just to make sure everything gets all hammered out there. As for engineering and contractors, hiring them, we gave it 2 months a pop for both engineers and contractors, but with current labor market, based on how tight it is right now, that could run longer. And then getting everything approved and getting everybody on the same page, we gave it another 2 months just to get everybody on the same page, just basically put pen to paper. And then as for construction, we gave it another 4 months to get materials on site, and then to prepare the area, let everybody know what's going on, and to actually start construction, we gave that, we put that in there as well.
So for the distribution impact analysis, we chose to use one of the nodes in Cheyney University, which is the one at the intersection of University Circle and Carver Drive. This node has a maximum PV capacity of 1.5 megawatts, whereas as you will see in the next slide, our maximum PV system that we are proposing is of 1 megawatt. So the nodes are capable to sustain the amount of solar generation that we are proposing. Then the simulation results of the parking lot area 1, which is our biggest power generation design, had a production of more than 1.24 gigawatts hour, and if there is any excess solar energy, would be stored on a battery system if implemented. Then the equipment that we used throughout the entire design was monocrystalline cells, since they count with a higher efficiency than other PV panels. All system designs have an inverter with a DC to AC ratio of 1.2, and those are module names that we used for the simulations.
Oh, we do have a battery storage for consideration. We run simulation based on the battery system is used for peak demand shift to reduce demand charge. According to the energy tool base simulation, 583 kilowatt hour is a good amount to choose for save more for our customer. 250 kilowatt charge rate is according to the maximum difference between the power reducing and the power consumed. Our discharge rate is 600 kilowatts according to the maximum annually demand. We assume $500 per kilowatt hour is cost for our battery system. Of the total amount costs were around 300,000. 583 kilowatt hour capacity were good for us to spend 5 hours if the external power cuts out. Based on the simulation, we find 48 years were needed for cover the battery investment. So that's why we did not recommend to install the battery system in our project. But if the loss of unexpected power cutting out is magnificent, the battery system will still a good choice. Next, our first proposal is includes 3 buildings, 3 locations of a total capacity of 758 kilowatt. The first location is at the Geo Library. It's a rooftop panel design and with a total of 306 panels and total capacity of 117 kilowatts. It's no tilt applied, and we leave some space for as walkways for later easy access and maintenance purpose. Next. The second location is at Berkeley Science Center, same as the first one. We left some room for as walkways and no tilt. This system include 810 panels and with a total capacity of 311 kilowatts. Next. And the third is the east-north parking lot. Is a small area. In this location, we installed 847 panels and with a total capacity of 385 kilowatt. And the panels were placed at a height of 12 feet from ground, and there is some space we left between the arrays is considered for aesthetic purpose and usability. This is our designs for the inverters and power array and how the wires go of these 3 locations.
Yeah, so the financial analysis for the first design, we had a total cost per watt of $1.64. Then we had an aggregate project cost of $1,739,000, and we gave it a PPA price of 0.075 with a 2.75% annual escalator. No SRACs were applied to the system, and the project and cash IRR results were both 10.11% and 10.8% respectively.
Our second proposal is basically put 2,680 panels on the west north parking lot. It's a big area, the area nearby the small. We put carport on the parking space, and on this design, we as a similar to the last parking lot design. Yes, this is our wiring and inverters for this system.
So for the financial analysis of the second system, we gave it a higher cost per watt because it is a bigger PV system, and also is all constructed with carpools, so they are bound to cost more. The aggregate project cost was $385,000 million, and the PPA price was 0.3 with a 2.75% annual escalator. So SRECs were applied at a base cost of $40 and with a 5% yearly increase, and this gave us a project IRR of 17.13% and a cash on cash IRR of 9.85%.
Comparisons and recommendations. We recommend the first system because of a lower PPA price. It does not require selling renewable energy credits, which allows Cheyney to promote the fact that they're generating green energy. And then although the production of the system is smaller, The demand for Cheyney is not that large as well. And then finally, the construction costs are cheaper. And that's it.